Hello, in this video I'm going to solve the following problem for you. A particle moves in the xy plane so that its coordinates x and y satisfy the following equations. X double dot equals to ay dot and y double dot equals to minus bx dot plus 1, where a is less than b and greater than 0. These are constants. If the particle is initially at rest at the origin, its velocity vector traces a portion of an ellipse in x dot y dot plane over time with eccentricity e. What is e in terms of a and b? That would be a good idea if you pause the video at this point and give it a try yourself. If you do the calculations correctly, the final answer will be e equals to square root of 1 minus a over b. Okay, so these are the given differential equations, and the initial conditions according to the problem are these four equations. The particle initially isn't at the origin, so x of 0 equals y of 0 equals to 0, and the particle is initially at rest, so it means the components of velocity at time t equals to 0 are both equal to 0. Okay, so let me start with this equation. It's very simple. X double dot equals to ay dot. Okay, I integrate both sides of this equation with respect to time. So x double dot now becomes x dot, and a is a constant. Y double dot becomes y. Of course, I have to introduce a constant of integration that I can use the initial conditions to find it, yes? Okay, so this is an equation for every time t. So what I will do, I will write it for time 0, so it becomes x dot of 0 is equal to a times y of 0 plus c, but y of 0 is 0, x dot of 0 is 0, so it means that my constant of integration is also 0. So this means that c is 0, and if I put it back into this equation, then it means that x dot is just simply a y. I will keep it for the future. Now, I will replace x dot in the second equation with a y. Okay, so then it becomes what? Then it becomes y double dot equals to minus b a y plus 1. I move the first term on the right to the left. It becomes y double dot plus a b y, and on the right hand side I am left with 1. So now let me introduce a variable. I introduce omega squared to be ab. First of all, this is possible. Omega, because a and b are both positive, so ab is a positive real number, so I can find a positive omega so that its square is ab. Why did I do that? Because then it becomes very similar to the harmonic differential equation. So it becomes y double dot plus omega squared y. But of course, in the standard harmonic oscillator differential equation, you have 0 on the right, but here I have 1. So technically speaking, it is a non-homogeneous second order linear differential equation. And from courses on differential equation, you know that in order to find the general solution of this equation, I need to find the general solution of this equals to 0, the homogeneous part. I need to find the particular solution for the non-homogeneous part, and then add them up. I will get the solution for the I will get the general solution for the non-homogeneous differential equation. But of course, if I put this equal to 0, if I put the left-hand side equal to 0, this is exactly the standard harmonic oscillator differential equation. And we already know that the answer is a constant, say alpha, cosine omega t, plus another constant beta sine omega t. But of course, it is very easy to see that y equals to 1 omega squared is also a particular solution of this non-homogeneous differential equation. Why is that? Because omega squared y becomes simply 1, and y double dot is 0. So that's correct. And then I add that to the general solution of the homogeneous one, and now this is exactly the general solution of this differential equation. Okay, Now I apply immediately this initial condition. What does it mean? It means that if I replace t with 0, y should be 0 as well. But when I replace t with 0, this is gone because sine of 0 is 0 and cosine of 0 is 1. So I will get alpha plus 1 over omega squared, and the output is supposed to be 0. Okay, so y of 0 equals to 0 implies that alpha plus 1 over omega squared is 0, as I explained. So then it means that alpha is minus 1 over omega squared. Okay? Now, what I can do, I want to use another initial condition here, but in order to do that, I need to know y dot of t. So I differentiate this relation with respect to time, so it becomes minus alpha omega sine omega t plus beta omega cosine omega t, and now I apply the condition that y dot of 0 is supposed to be 0. What does it mean? It means that if I go here and replace t with 0, the answer is supposed to be 0. On the other hand, when I replace t with 0, sine of 0 is 0, so everything here cancels, but cosine of 0 is 1, so it means that I will get beta omega is equal to 0. But omega is a positive number, so the only possibility is that beta is equal to 0. Okay, so now what I will do, beta is 0, alpha is minus 1 over omega squared. I put them here, I will get my y. So y of t is equal to what? Is equal to minus 1 over omega squared cosine omega t plus 1 over omega t. This is my y, and if I put it in this relation, I will find my y dot. So y dot of t becomes equal to, let us see, minus alpha times omega. Alpha itself is minus 1 omega squared, so it becomes what? 1 over omega. So it becomes 1 over omega sine omega t. And because beta is 0, so this term cancels out. Yes? So this is what I have. Okay, so and if you don't mind, let me multiply everything by omega. So this means that omega, and if you don't mind, let me just drop the time here. So omega y dot becomes equal to sine omega t. So this is one relation that I will need soon. And then what I'm supposed to do now, I want to find x dot. Yes, x dot can be calculated using this relation. Just multiply your y by a. This is your y, so just multiply it by a, you will find x dot. Okay, so x dot becomes minus a omega squared cosine omega t plus 1a over omega squared. Okay, and now if I multiply everything by the reciprocal of a over omega squared, then this becomes omega squared over a x dot is equal to minus cosine omega t plus 1, and I move 1 to the left, so it becomes omega squared a x dot minus 1 is equal to minus cosine omega t. And I want to get rid of time, so this will motivate me to square this one, so it becomes sine squared, square this one, so it becomes cosine squared, and then add them up. Because sine squared plus cosine squared is 1, I will get this relation, so it becomes omega squared over a x dot minus 1 squared plus omega squared y dot squared is equal to 1. And if you're a little bit familiar of the equation of the ellipse, you can see this will be an ellipse because the coefficients are not the same in the x dot plane. Okay, Yes, so that it will be an ellipse, but I want to find the semi-major and semi-minor axis of this ellipse so that I can use them to find my eccentricity. Okay, so to do that, I need to make this equation a little bit standard. To make it a standard, what I will do here, I factor this coefficient out. Remember, there is a power of 2, so this becomes omega to the power of 4 divided by a to the power of 2 x dot minus a over omega squared to the power of 2, and then plus omega squared y dot squared equals to 1. So if you don't mind, let me take this with me to the other page. I do not have enough space here. Okay, so that was the equation of the ellipse that we have. Okay, this is the equation of the ellipse, and we introduce omega squared to be AB. So what should I do? Let me write this as a standard equation for an ellipse. To do that, I will write it as x dot minus a omega over omega squared to the power of 2 divided by, I would write it as a squared over omega to the power of 4, and then plus y dot squared. Instead of writing omega squared like that, I would write it as 1 over omega squared. Then you can see that you can compare it with this standard equation of an ellipse, yes? Of course, this is for the case that the origin is the center, but here the origin is not the center, so the y coordinate of the origin of the center is 0, and the x coordinate of the center is a over omega squared. Anyways, but let me also simplify this expression, because omega squared is ab, so omega to the power of 4 is a squared b squared. This a squared and that a squared are cancelled, so I will get x dot minus a omega squared to the power of 2 divided by 1 over b squared, and then plus y dot squared divided by omega squared is of course ab is equal to 1. But do you remember, it was given in the problem that a is less than b, so if I multiply everything by b, it becomes ab is less than b squared. Because all of them are positive, then it means that 1 over b squared is less than 1 over ab. So then it means that the semi-major axis has length equal to 1 over square root of AB, and semi-minor is 1 over B. But we know that the eccentricity of an ellipse is a square root of 1 minus semi-minor divided by semi-major, and then totally to power 2. That is the formula of the eccentricity of an ellipse. So in this case, it becomes a square root of 1 minus 1 over b divided by 1 over square root of ab, and then totally to power 2. So then it becomes square root of 1 minus 1 over b squared over 1 over ab. And then if you cancel b's, then it becomes square root of 1 minus a over b, as is demanded in the problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.